So let us get into working out these questions we have on the screen, right? Thank you, Joshua, after the fact, right? So we're going to work out 3 simple questions of revision before we get into the new topic of algebra, the newer topic of algebra. So the first question is the sum of 3 consecutive numbers where x is the smallest number. So consecutive, we just reviewed that consecutive means, you know, immediately after, right? So immediately after. So if we were counting 1, 2, 3, that's a consecutive order 4. So they said x is the smallest number. So we know, oh, and it's the sum. So we are going to add 3 consecutive numbers. So if they had said the sum of 3 consecutive number, 1 being the smallest number, we would have said 1 plus 2 plus 3. But our smallest number is x. So it has to be x plus another number, well, plus the number after x, plus the number after the number x, right? So what will be our number after x? If we follow this flow, the number after 1 is 1 plus 1. Number after 2 is 2 plus 1, right? So we take the previous number and we add 1 to it all the time. So from that, we know that the number after x will just be x plus 1. A lot of persons like to say y, but we can't say y because it's not the alphabet we're using, it's algebra. So the number after x would be x plus 1. And the number after x plus 1 is x plus 1 plus 1, because we have to take the previous number and add 1 to it. So if we look at that, if we simplify this, it will be x plus 1, removing this at the side here. And of course, if we have x plus 1, that would just be x plus 2. And we can go ahead and add up our like terms from what we were doing last class. So we have x plus x plus x. We know that the coefficient in front of these will be 1. So that's going to be 3x. And we add up our numbers, which will be positive 1 plus 2. So 3x plus 3. And that is our answer for the sum of 3 consecutive numbers where x is the smallest number. So smallest number x, number after that will be x plus 1. The number after that will be x plus 1 plus 1. When we simplify it, that'll just be x, add x plus 1, add x plus 2. We add up the like variables, which are the x's. We'll get 3x. Then we add up the constants, which is 1 plus 2, and we will get 3. Do we have any questions?
How come for the third number, we didn't say 2x plus 1?
Why would we do 2x? Where did 2x come from?
Well, the 1, remember you said once a variable have no number before it, it is assumed that there is 1. So
it
that
is,
1 plus the
1.
Well, it's 1. That 1 plus the 1 is 2x. That's all.
This one?
Yeah, plus that next one is 2x.
Those are unlike terms. You can't add 1x plus 1.
Oh.
Yeah. So 1 is a 1x and 1 is a 1. Same way we have 1x, 1 and 1. 1x, so that's why at the end we added up the 1x with the 1x with the 1x and the 1 with the 1 with the 1 to get 3x plus 3. Yeah. So always be mindful that you cannot add or subtract unlike terms. So for substitution of number 2 now, we have -5 and we're going to substitute where x is 2. So that's going to be 2 cubed alone. The cube is only on the x, so 2 cubed by y, which is -3, over -2 by z, which is 4 squared alone, The squared is on the z alone, not on the entire thing. So that's going to be -5 by 8 by -3 all over -2 by 16. We can multiply all of these together in our calculator. -5 by 8 by -3 will give me 120 over -32. And this is improper, so I can say 120 fraction sign -32, and I'll get -3 3/4. Do you have any questions? All right, so
is it possible you can scroll back up, please?
So the second question was substitution. Now the third question is not about substitution, it's about simplifying. And when we look at the question, they are x squared, y squared. So how do we simplify these? Now this is now adding and subtracting algebraic variables. So what we do is we know that the rule is we can only add or subtract like or common terms that has the same variables. So we group them together. 15x squared can work with -9x squared. And we put -6y squared. Remember, the sign in front is associated with the number. So -6y squared plus 3y squared. So now we can work out 15 minus 9. So that will be 6x squared. And then remember, this is a -6. So don't say 6 plus 3. This is a -6 plus 3. And when we put that in our calculator, that will give us -3y squared, or the rule for addition and subtraction. When the signs are different, we subtract and keep the sign of the larger number. So 6 minus 3 will give me 3, and the larger number is 6, so I take the negative. Yeah, so number 2 now, same thing. Take the like terms, p squared with p squared. That will be 5.7 p squared minus 2.3 p squared. We have plus 3.9 q squared minus 1.5 q squared. 5.7 minus 2.3, that is 3.4. We put the same variable, p squared. We do not touch the variables when we're adding or subtracting. Now, positive 3.9, subtract 1.5, that will give me 2.4, positive 2.4, and same variable, q squared. So now we are moving on to multiplication and division of algebraic terms. So before we would have done addition and subtraction of algebraic terms. And we know that the rule for that is that we could only add or subtract like variables. So my variables has to be exactly the same for me to add the coefficients, right? So we have an x plus 2x. We could work that out as 3x because 1 plus 2 is 3, and we put back the same variable, which is the x, right? Now, if this was 1x plus 2y, we can't add these because they are unlike variables. Now, for multiplication, it's a little bit different. If we recall, x multiply, and pay attention, it could become a little confusing when you make your x like this and your multiplication like this. So I try to curve my x a little and make my multiplication straight to identify the difference between the two. So x multiplied by y will just be equal to xy. We just place them next to each other, or yx, which we knew from before. The order is not very important, but to keep it simple, we try to keep it in alphabetical order, right? So the rules for same variables when we are multiplying or dividing is that we add the powers. So when multiplying like variables, we add the powers. When dividing like variables, we subtract the powers. Pay attention. Just like how x is equal to 1x, x is also equal to x to the power of 1. So if I have 3x multiplied by 5x, remember it's multiplication, so it's going to be 3 multiplied by 5. And x multiplied by x, the powers of the x will be 1. So that's going to be 1 plus 1 because we have to add the powers of same variables. So that's going to be 3 by 5, which is 15. X by x, which is x to the power of 1 plus 1, which is x squared. So 15x squared. If we try it again.
Let's say you're treating the variables and the constants separately until we reach the final stage of the calculation. We gotta bring everything together.
Yes, so this is just the explanation step, right? So we only write this now so you can see what's happening, but usually you could just go straight to this step because you already know 3 by 5 is 15, x by x, 1 plus 1, x squared. But this, as you are now learning it, I'm showing you how to actually get the answer, but this is not a required step for you to write down. Yeah?
Yes.
So we have a half p by 8p. Yes?
Now I was going to ask if we write it down. Right.
Yes, I was. Yeah. 1 second. So I'll go ahead and explain it and then we'll pause it and you can write it down, right? So a half p by 8p, that will be a half by 8 number multiplied by number. And p multiplied by p, we know the powers will be 1 and 1. So that's just a half multiplied by 8 is 4. And 1 plus 1, that's just 4p squared. So the third example, we have 5 by -3, which is -15. And so we see that the rules of the signs are coming back into play as well. So we have to remember the rules of a sign, a positive number by a negative number is a negative number. So 5, a lot of persons say 5 minus 3. Remember, it's multiplication. So 5 multiplied by -3, that's -15. And y by y squared, the power here will be 1. So 1 plus 2 is 3. So that's -15y cubed. Now, more variables, more than one variables. We have 4 by 3, which is 12. P squared by p cubed, that's 2 plus 3. So that's p to the power of 5. And q cubed by q, that would just be q to the 1, so 3 plus 1, that's 4. So if you pay attention, we are only adding the powers of the same letters. You don't add a q to a p. You don't add a p to a q, right? It has to be the same. So if we have something like 4p by 2q now, we go back to the regular way of doing it. 4 by 2 is 8, and p by q is just p. Q. So when they are unlike variables, we just place them next to each other because we cannot add their powers. So for division of variables, we divide the powers once they are the same. We subtract the powers once they are dividing, right? So x squared divided by x squared, that's just 2, subtract 2, which is x to the power of 0. Anything to the power of 0 is equal to 1, so that's 1. Now we have 15x cubed, y cubed, z over 3xy squared. Joshua?
In order for you to subtract, the variables must be the same?
Yes, same thing for when we're multiplying. We can't add them if they are not, we can't add the powers if they are not of the same base variable.
Okay.
Yeah, So we divide the numbers. 15 divided by 3, that's just 3. X cubed divided by x, so that's going to be what? X3 minus 1. Remember, this is a 1. And then we have y cubed, so y3 minus 2. And then we just have a z, so we just put z alone because there's nothing for us to work out. So our answer will be 3 x squared y1 or y, anyone, z. Let's try this other one, 6a over 2b. So we see that 6 over 2 could be 3. Now we have an a on top, nothing to work out with the a, and we have a b at the bottom, so we put back the b at the bottom. So anytime you didn't touch a variable, you leave it back in the numerator or you leave it back in the denominator. You don't just go and put 3ab, right? Because remember, a and b are dividing. Don't change it to multiplication. So we divide, 6 divided by 2 is 3. On top, a, on top, b at the bottom because we didn't touch those variables.
Excuse me. Could you go back over the example 200 please?
Sure, no problem. So for this last example here, we have 18 divided by -3, which is -6. Dividing like variables, so p cubed divided by p, we subtract the powers, 3 minus 1, because we know this is a 1. And then we have q, 4 minus 2, because 4 at the top, 2 at the bottom. That will give us -6 p squared q squared. So going over example 2, 15 divided by 3 is, sorry, that's 5. 5 x cubed divided by x. So remember, we're taking away the power, so 3 minus 1. So 3 minus 1, and then y cubed divided by y squared. That's 3 minus 2. And then we just leave the z on top because there's nothing at the bottom for us to work out with the z. So we're just going to end up with 5x squared, y to the power of 1, or just y, and z. Now, for example,
wouldn't it be because y has no, z, we know that it is implied that it is to the power of 1.
Yes.
So when z divided by z, wouldn't that be 1 minus 1, which is 0, and then it would be 1?
What z? There's no z at the bottom. There's
Oh,
just one z at the top. This is a 2 squared.
Oh.
Yeah.
But if it had a z there, that would how
it would be just like this one. Yeah. Z over z is 1. Yeah. 1. Well, 1 minus 1 is 0 as well. So z to the power of 0 will be 1. So for the third example, 6a over 2b, we divide 6 how we would usually divide 6 over 2, which will give us 3. I would place the a back in the numerator and the b back in the denominator because we had no working out to do with them. They are 2 different variables. You can't subtract any powers. Any questions?
No, just take all the questions.